Okay, this is a distribution of sample means via the central limit theorem, specifically finding probabilities. Now, there's other uses of the central limit theorem. It's not just restricted to just this one example. So keep that in mind as you read the book and you've seen. I think they might have a uniform distribution example in there, and it's much more than what you're seeing right here. What I'm saying. Now, the same principle holds true though. Examining your what the mean and what the standard deviation or variance, depending upon which way you look at it, goes to. Now, just a review for the probability piece. Find the probability, percentage, proportion, or area includes unusual. Unusual is less than 5%. Whenever you see those words, then you want to use p-norm. And it was putting in the x, then the mu, and then the sigma. Now this does not include what we're looking at here. This is going to be altered, and that finds the probability to the left of x. Okay, so building upon that, when you're talking about distribution of sample means, we want to identify the expectation or the mean, and that'll just be our mu. Identify the standard deviation, and that's going to be our standard deviation divided by the square root of n. The book focuses on variance a lot, but since our function is focused on standard deviation, that's why I put it in this form. And use table on the following slide to determine how to enter the function. If you got probability x is less than or equal to a, or x is less than a, whether it's less than or equal to or less than, same with all of these, then it's the same formula. And we're going to use p-norm, then a comma mu comma sigma divided by square root of n. If you got probability of x is less than or greater than or equal to a, you do 1 minus p-norm, a comma mu comma sigma divided by square root of n. And then if it's between two values, a and b, use p-norm b mu sigma divided by square root of n minus p-norm a mu sigma divided by square root of n. Okay, so let's take a look at this example here. Test grades are normally distributed with a mean of 70 and standard deviation of 2. Okay, so mu, oops, mu equals 70. And I don't have to put these separate. I could put them right in this one line, but I just want to emphasize this. And then this one, standard deviation of 2. So that would be our sigma, according to our formula. Sigma equals 2. And then we want to find our first one. So, first example. For this one says, what is probability a random sample of 15 test grades have a mean less than 69? So n would be 15. And we're finding the probability that, and this is referred to as our sample mean. So x bar. Now, I know it doesn't say sample mean, but since we're referring to the random sample and it's a mean, that's sample mean. Less than 69. Okay. Okay, the less than case. I come up here. The less than case is this first one. P norm, A, comma, and A is what follows your less than or equal to symbol. So, P norm, 69, comma, and then mu, then sigma divided by square root of n. Mu, sigma divided by the square root of n. And that'll give us our answer. Let's run that. And that'd be our probability. Okay, print our second example. This one. What is probability that a random sample of 20 test grades have a mean more than 69? So n would be 20 in this one. And we're finding the probability that our sample mean is greater than more than 69. Okay. So greater than 69. Well, a greater than case. That's our second one here. And we're going to use 1 minus p norm. It's 1 minus p norm x and mu sigma divided by sigma divided by square root of n. And that's just off this right here. And then our third case, our third example. But I didn't run that one today. I'm going to go and run it again. Okay, so there's our first one, and then this is our second one, which makes sense, because less than 69, greater than 69. Oh no, that wait a minute, n is different. Never mind. So they don't add up exactly to 100% anyway. Okay, third example. What's probably a random sample of 10 test grades have a mean between 60 and 71. So n would equal 10. Now, between two values, 60 and 71. Okay, so probability that our x bar is between 60 and 71, including 60 and 71. That's this last case here. Now, a's are a smaller number and b's are a larger number. So we're going to plug it into this. So we put our larger number first, smaller number second. So we're going to have p norm 71, comma, our mean, which is mu, comma, standard deviation, which is sigma, divided by square root of n, minus p norm, smaller number, which is 60, comma, mu, comma, sigma, divided by square root of n. And run that again. I got an error. Oh, uppercase n. Let's try that again. Little n. And that would be our probability. And those are your three cases. You less than, you greater than, and you between. And like I said, the central limit theorem is much more than this. This just gives you an example based upon the sample mean.